So inclusion to create the module of that. Okay.
There's no project. There's no update.
So no, you said we should do batches.
Yes, one of the
both of
projects.
them. And they help us.
You guys are
But the only people should be able to hear.
yes. Like they can even hear us automatically. No, it's
This one. So one understand. No, sure. What's your are we doing it? I'm so sure I'll be checking. That was broken. So check is that no, it's showing the phone. The code has broken.
this would be a challenge. So it would be a challenge if I could just work to English but I'm not just English project.
Yeah, that's a customer. We don't know the number of difference.
This
Okay.
yeah, good stuff.
Yeah, great.
All right, thank you so much. And we are welcome back to class where we stopped yesterday. So we have been able to, okay, let me just make this border. Yeah, I want to believe we can see from. Okay, so yesterday we stopped here where we were able to build different vectors, 3 vectors particularly, that has to do with months, cases, and then a rainfall. Well, how many of us were able to generate these vectors yesterday? Okay, and you realized that we said vector is the most important building block of our data in R, because now we are moving on to something else now. We want to put together these things that we have created called vector into data frames. So we say organizing vectors into tables. Of course, you know that in your Excel sheets, you have when you put any data in Excel sheet, it looks like a tabular form, right? Where each of the column You have your column and you have your rows. Are we together? And then the columns are the variables, right? While the rows are the observations. Am I right? Are we together? The columns are the what? Represent the variables that you are measuring, for instance. And then you have the rows to represent the what? The observation. So now, imagine that yesterday we had 3 variables that were observed, that were recorded. What were they? With our vector. Months, cases and what? And rainfall. Those are variables, right? We may want to organize those into, into tables, right? So it is vectors that you organize into table. Are we together? So each column of a table or of a data is a represents the vector. Are we together? So in that's why we said a data frame in our work us for tabular data. Each row, each column is a named vector. Are we together? And each row is one observation. So that's why I said you should think about it like your Excel. Now we are going to do something now. We want to put that the vectors that we built. I told you that the vectors now are the variables. Most of us, if you are used to data collection, the variables are the object of interest, right? That you have collected. Is that not so? For instance, you can have age, isn't it? Demographic variables. You can have climatic variables. We can have cases, things that are related to epidemiology. But here we have built 3 variables. One has to talk about time, which is in what? Months. Are we together? The other one has to talk about what? Cases. And the other one has to talk about rainfall, which are climatic variables. So we have built them yesterday, and you all have them with you already. Now we want to now assemble it and make it to be in a table. So what do we do now? Please let's be together. So we say data frame. Data.frame is a function in R that we use. Is that okay? Data.frame is a function that we make use of in R to actually assemble our vector. Is that okay? Now, we are also going to make use of something as we go on, factor, because I need it as we go on in the different data frame that we are going to be building. Factor. What factor does is that it's also a function in R. What it does is that it converts a character vector into a categorical variable with a defined order. You know that you have character or strings, as we talked about yesterday. Data, for instance, if you have your data can be numerics, right? We can talk about age, right? We can talk about can you give me numerics? Factor, data that can be numerics. I've talked about age again. Weight, even case, are they not numerics? A number of cases, malaria cases, they are numerics, right? But there are some that are not like that. For instance, we are talking about, can you give me any data that will not be numerics, will be string, name, right? And some of them may be ordinal, right? That is, they can be categorical in nature. And when you have categorical data, you are talking about the order. Order is important. So, for instance, now you have a situation where you are looking at malaria risk. You can be talking about high, low, right? And what? Medium. Order is important in that situation, isn't it? And there are some other situations where order is not so important. All right. So now if you need to convert a vector into a categorical variable where order is important, then you bring in what is called factor. Is that okay? You know that in months, order is important because December cannot come before January. Is that not so? February cannot come before, March cannot come before February. So order is important. So one of our variable, which is months, we need to be able to ensure that it stays in order. The order is maintained. Are we together? All right. For instance, if you don't put it, if you don't put it in our months, it will just arrange alphabetically order. Are we together? And when it's arranged alphabetically order, we are going to be having April come before January. Is that okay? So we don't want such situation. All right, we're also going to be using something along the line because we also we built just an hypothetical data set that we want to use to also visualize along the line. So later we'll be using some random generate some numbers randomly. As we go on, we do random generation of numbers. So where we use some of our distribution, particularly we'll be using uniform distribution to generate numbers randomly. I'm doing that because we want to generate data hypothetically. So since we don't have any data at hand to use, we just generate hypothetically for our usage. Okay. Also, as we go on, and so when we have, so for such situation, when we have run and when you have R reunite, it means that I want to generate data using uniform distribution. So I'm generating random numbers using what? Uniform distribution. Is that okay? When I use rnorm, what am I doing? I'm generating numbers using random numbers using what? Normal distribution. Are we together? Yes, I'm not going into the statistics of it. So I'm just telling you that you can generate random numbers by yourself. So if I use R coas, what am I doing? I'm generating random numbers using what? Poisson distribution, right? So you can generate random numbers by yourself or in order to just get a data. Okay, but let's work with the data that we are already familiar with. This is what we all are going to do now. So you are going to be writing to type. Now, what am I doing here? I'm not going to talk. You will tell me what I'm doing here. What am I doing here by just doing this? What do you think? This highlighted place, what am I doing there? What is that meant for? Yes, somebody said something like now. What am I doing here? So meaning whatever I want to do after now, I'm assigning it to what?
To the month.
I need response. We did this yesterday together.
I'm
not talking about the right hand side of that. What I'm just highlighting, what does it mean based on what we did yesterday? Can you remember? Can somebody remember? Somebody has said it. You want everybody to echo it. What am I doing?
You are assigning data.frame to df underscore monthly.
Good. So our online participant has answered. He said we are assigning this data that we want to create, we are calling it a name. And what name are we calling it? df underscore monthly. Is that okay? That's the name I want to call the data that I want to create now. I'm about creating a data set, but I want to call it a name. Are we together? You can call your data any name. The name you can remember to say. So, yes. And in creating this data, I told you that there's a function in R called data.frame. Data.frame. So you go to your R now, open your R studio. So we want to create this data set, which I've called df, right? Underscore df underscore, what did I call it? Monthly. Good. So how do you assign? I think I told you the shortcut of doing that. Alt minus, that's good. So data dot frame. As soon as you are typing it, it will even bring it. Data dot what? Frame. You can see data dot frame. Now you see two things here. You see one, data dot frame and data underscore frame. Both are good. You can use both of them, but one is coming from the player function, right? And the other one is just from your base R. Base R means that even if you not install any package, you can use that function. You know, I told you that many functions that we use in R, they are located in packages, right? But there are some functions that are in R itself without installing any special package. Is that okay? So they are called functions in base R. Do you understand? Do we get? So they are called functions in base R. But you will see that we can also, the other one is data underscore frame. And you see in front of it, you see dplyr in front of it. Did you see dplyr in front of it? That means if I want to use dplyr, I want to create data frame using dplyr, language of dplyr, then I'll be using data underscore frame. Is that okay? But it's sufficient for me to go with base R since I can just use base R. So I'll go with data.frame. Both of them will do whatever I want to do. So in creating a data set, one, you know that we have said each column represents what? A variable. Is that okay? So, and each variable, you have a variable name, isn't it? Like we had yesterday month, that's a variable name. We had cases, that's a variable name. Is that okay? And we had what? Rainfall, that's a variable name. So we are going to be bringing in a variable name and what the entry for that column we are going to be putting in. So you will now do that here. So just after you have written data.frame, open your brackets. Let's open brackets. Open bracket. Are you typing, everyone? Now you have month equals to, don't forget that originally we would have just say month equals to months that we created yesterday. Right? Now, if you have shut down your system, you need to run the things that we did yesterday again, because we are taking the months, we are taking the data, cases, and the rainfall from the one we created yesterday. So it's like we are continuing. So because if you run this one without running those ones earlier, it will tell you that they cannot find it. I've told you, you must first declare anything before you make use of it. So open the same R file that we opened yesterday, run those things that we ran before, particularly from the vector months, cases, and rainfall. Run it again because we need it in what we want to do now. All right, thank you. So now for colon month, what do we want to be there? What entry do we want to put inside colon named month? So this is the name of the column. This is the name of the column. So let's name the column month equals to. So when you say equals to, what you put inside, what you put in front of it is the entry of the column. Is that okay? The left hand side is the name of the column. The right hand side is what? Is the entry of that column. Okay, so let's put equals to. Now, factor, I've told you that because I don't want R to arrange it in alphabetical order. I want it to still maintain January to December. So just put factor equal to months and then levels equals to months dot ABB. So I'm saying that arrange it according to this order of abbreviation. So from January to December. That's what I'm saying. You have created months before already, so we have created that before, and then close that first bracket with factor and put comma, Are we typing already? The same thing you have here is what we are going to type in R. This is the code that you are typing. So, comma. Then you go to just to make it look neat. So just click enter so that you go to the next line and type cases now. So on the left hand side is the name of the column, right? On the right hand side is the entry. That is what I want to fill that column with. I want to fill that column with something I've created before called cases also. I've created cases already. So just say cases equals to cases. So it takes the left hand side as the name, and it takes the right hand side as what to fill it with. So cases. So you put comma again. Each of the column that you are creating, you must separate it with comma. If not, it will not separate correctly for you. Then you go on to rainfall. Again, the name of the column I'm creating is what? Is rainfall. But the entry is what? Is what the entry of that rainfall vector that I created yesterday. So again, say rainfall equals to rainfall. So if I have not created a rainfall vector before, it's not possible for me to use it like this. It's because I've created a vector called rainfall. So it's just going to be extracting of the content of that rainfall. So once you have that, run. So close the brackets here, close the brackets, and then run your df underscore monthly. Run it. Run it. Have you done that? Let's move very fast today because I have some things I want to. Like if there's a time, everything he has taught you in modeling, I would have loved to execute them using how. Yes, because I have them. I think I gave you the codes already, so they are there. You can run them by yourself later. Please, I want everybody to be working, and then I would like to get feedbacks from us. Even if you don't have a computer, sit with somebody that has a computer, and then do it together. So somehow it's when you go back to go and do it yourself, you are able to get what we are doing. Okay. We start now. It's until you put the content. You must put the content before you run. The content you must put are what I've displayed. See what I've displayed. Just look at df underscore monthly, right? And you have data.frame, open bracket. Then the first column is what? Month. What do we feed it with? What do we want to be inside months? Is what's at the right hand side of that month. So the next thing, the next column we want to create is the column called casing, right? Casing. And then what we want to feed that column with are the things that the cases we created in the plan. I just say cases equals to it because I already have the vector that BSCC, which I ask you to run. If you don't run it, it will give you a run. So, and then the next column I want to create is rainfall, right? So, what do I want to fill that column with? They are the rainfall data that I created yesterday, vector that I created yesterday. So, put it again, rainfall. It's also possible that if I don't want to be saying rainfall equals to rainfall, I will say rainfall equals to, and put the vector itself C into the bracket and the number two. Just like we created the vector yesterday as C into brackets, we calculated and then put all the entries there. But because I've created that rainfall vector before, there is no need repeating it. So I just say rainfall, equals to rainfall. So it takes photograph on the left hand side as the name of the column, and it takes photograph on the right hand side as what you fill the column with. Is that okay? Okay. Somebody will help you. Just put up your hands and then they will come and help you. So have you run it? Who has succeeded in running? Good. Okay, I love that. Now you can now call out your GF underscore monthly. You can just rewrite it and run it, or you highlight and run. So when you highlight and run, what do you have on your console? Do you have something that looks like my home? Yes. Do you have something like this? Okay, so what do you have in your console? Oh, good. So read your error message. Unexpected symbol, that's a good one. Yeah? In what? Okay. It says unexpected what? Read the full something. Uh-huh. Help. Yes. Okay, that means you didn't run what I asked to run then. So when it says unexpected character, that means you have put something that is not supposed to be inside the data frame function. So you look at your data frame that you have just written. Did you write it like I asked you to write it? Yeah? Okay, so now when you have such situation, then that tells you that what do you have as your months? The name you might have had mismatch of name. What did you use to put months yesterday? Months. So you look at everything you have put down. Don't forget ask you to run the vector of yesterday. So check again and be sure that you are putting the correct thing. Okay, how many of you got what I got? Okay, good. I have some people who got it here. That's very good. So you have this table, right? Good. Now, when you create, while they are helping people to, if you're having any challenge, put up your hand. People can help you. There are people that can help you around. Dollar Mr. Sam, please help me to help people. Some people are putting up their hands. Okay, so if you have gotten it, that means you are also a facilitator then. So check what they have done. Yes, you can help others. You can help others. Since you have gotten it, just help others. So you can put up your hand if you need help so that people can help you. So let us learn together. You see where you have made mistake. Okay. of your data frame that you have created. What's the name? DF underscore monthly, or if you are calling another name, just put the name down and run it. Once you run it, it will open another tab for you where to display data period. So did you do that? Which okay, thank you so much. So let's move on. We have now created, use the data set that and the vectors that we have yesterday to create a data frame, and then you have something of this nature, something like the one I have here. Okay, so let's move on. So you notice that each column is simply one of the vectors we already defined. Yeah, it's just for you to be able to notice that. And the data frame keeps them aligned row by row, making it easy to plot, filter, or summarize them together. So when we want to analyze, you can analyze that as now let's see something now. We want to create another data set. I call it a richer district level data frame. Let's assume that that data that we just saw, that we just finished creating, let's say that's meant for a district or meant for a state, right? Supposing we have, say, about 8 districts. Are we together? We have 8 districts and we have the same data. We want to create, I want them to be on the same table. How do we go about that? So now we are going to create hypothetical data now. You know, I mentioned the other time that we can create hypothetical data using our random to generate a number randomly, right? We can generate numbers randomly to create hypothetical data. That's what we want to do now. Are we together? So I'm going to be using more of the uniform distribution to generate this random number. And the way uniform distribution works is that now you need to first specify, you know, I have R unique. That means random numbers that are generated with uniform distribution. What you have inside of it, they are called arguments. Any function that you have, any function in R has what's called arguments. What we call arguments are the things that the function can take. Is that okay? In order to function properly. Is that okay? For instance, now, there are things you must put inside a certain function for it to respond to you. Do you understand? Each of the functions created in R, they have the way they are created. And so it's just the same way. Imagine you, okay, some of us can still remember math. If I have f of x equals to x squared plus 1, f of x equals to x squared plus 1. That means whenever I want to supply something, I should be supplying x values, right? Imagine I now said, I want to supply, I'm having my x now, and I supply a comma b comma 2 comma 1, where my x is just supposed, it's not a function of many variables, it's just one. It will not take it. It will just simply tell you that it does not know how to use it. Is that okay? So now every function created in R has what we call arguments. Arguments are the components, the things that the function can take. Is that okay? So for this R unit, for instance, now this random generated number using uniform distribution. Now the first thing here is the number of outputs that you want it to generate. Is that okay? We want it to generate. You know that we are talking about 8 districts. Is that okay? So the number of outputs you want. Are we together? And you also need the minimum value and the maximum value, because a uniform distribution, if you are familiar with distribution, needs 2 parameters, the minimum and the maximum. Is that okay? You need the minimum and the maximum because the formula is f of x equals to 1 over a minus b, where a is the maximum, or b minus a, where a is the minimum and b is the maximum. That's the maths. Well, we're not talking maths. So, but we necessarily need those A and B, the minimum and the maximum. So you must specify. So as you go on there, you see what I'm talking about. Also, I'm going to be needing this paste function. Paste. You can see paste, right? Did you see paste? And I have districts, and then I have letters 1 to 8, right? Now, in R, when you type these capital letters that you see there, letters, all the letters of the English alphabet, A to Z. Once you just type letters, for instance, in your R and run it, you see to give you A to Z. You can type either, if you type it in small letters, to give you small letters, A to Z. If you type it as capital, to give you capital letter, A to Z. Is that okay? So I want to create district A, district B, district C, district D, district E, district F, district G, and H. 8 of them. I want to create 8 districts. Is that okay? And I want those districts to take letters, the first 8 letters. Is that okay? So that's why I have said, okay, take from letters, the first 8 letters. Is that okay? So, and I want you to write it as district A. I want you to write it as district B. I want you to write it as district C. So paste help us to combine the word district and each of the letters together. Do you understand now? So that's why we said this one concatenates district with the first 8 capital letters to create district names. Because I want to create district names, so I need that. So let's go now. So if you look at now this, I have again here set seed. So when you are using randomly generated numbers, because it's randomly generated, if you run it 1 million times, you get 1 million different answers. Do you understand? But I don't want that. I want to keep the values to be the same. So what you can do is to set seed. It's like when you set seed, what you do is you want to track the first numbers that are first things that were generated. You don't want to be changing. Just to track that. That's what I want to be for. So when you set seed, to set seed helps us to control that. Help us to control. So there will be normally it's supposed to be randomly generated, and then when you run it different times, it will be giving different values. But I don't want that. So you set seed. This number 42 is just any number, it's just like code. It's just like if you have your key, this key that is you can set it to be anything. Is that okay? So it doesn't mean anything, it doesn't mean 42 is what it was. Is that okay? You can use 100, like anything you like. I've decided to use 42 here. So set seed. Because I'm using randomly generated numbers, that's why I've set seed. I don't want it to keep on changing each time I run it. So now n districts. I've said how many number of districts do I want? 8, right? So I've assigned n district to be 8. So you two should do that. Assign your n district to be 8. If 8 district wants to create 8 districts. And now, so we are now creating this data frame. And what's the name of our data frame? Check. What's the name of our data frame that we are creating now? What is the name of our data set that I want to look at what I've put up here? District. District is the name of our data set that I want to create. You can call it any other name you want. But now I want to call it district, right? So, and we said data.frame. Data.frame. Open the brackets. In order to create a data frame, what did I say we need? If you remember the last time, sure we need some things. We need the name of the columns, and the entry of the column. Do you understand? I need name of, now, if you are creating data frame, what you have in the data? Columns, right? These columns represent variables, isn't it? And then you also have observation. Are we together? So these variables that you have, each column has a name. Each column has a name. So we are naming it. So that's why I said in creating any data set, you just need name of the column and the entry of that column. Is that not so? Are we together? Are we together? So that's what we are doing now. So when you want to create data frame anytime you want to create data frame, you need two things: the name of the columns and the entry of that column. Is that correct? So in this case, it's the same thing. So if you tell me what do you think will be the names of this column and of this data set, or the columns of this data set that I'm about to create, based on what I put up there? Eh? The name of the columns. Can you tell me? Number one column is going to be what? Number two column is going to be what? Population. Number three column is going to be what? Cases underscore. The number four column is going to be what? Bed net percentage, right? And then the fourth column is what? Good. So if by the time you put all of that, we also need to have the contents, right? The entries of that column, which is on the right hand side, isn't it? So let's go on now. For the district, what do we have? Paste what? Paste what? District. Then letters. Our letters should be 1 to what? The number of district, which is 8, right? I explained this the other time. So what is this going to be giving me? District A, district B, district C, district up to district what? H, right? Do we understand? So that's what this paste is going to give me. So now I want you to do that. Just type the entry of this column. District equals to paste into brackets. Then you put colon, again district, and then letters 1 to 1, full colon, n underscore districts. And then this is square bracket. Oh. This one is square brackets. Yeah. And then you close that bracket. So that means you are done with that column. You have created the entry of that column. So, comma, the next column, which is supposed to be population. The next column, which is supposed to be population. You see that I put a round. So when you say round, that means you are putting to the nearest whole number, right? If you put round and you didn't specify what should they round up to, once you just put round alone, that means you are rounding up to the nearest, right, whole number. Is that okay? So what do we want here? We said randomly, we want to generate numbers randomly following uniform distribution, right? And then how many of such numbers do we need? N districts, that is 8. You know, our N district is actually 8. We need 8 numbers that are generated randomly and should be minimum from 50,000 to what? To 300,000. 50,000 to 300,000 for population. So we are generating hypothetical data sets by ourselves now. So when you do that, don't miss out on any of the parentheses. Open and close your parentheses properly so that you will not run into error. Okay? You want me to expand this more? You want me to enlarge it more? Should I increase it more? Okay. Is it better? Same thing. I think it's better now. Can we see it better? Okay. Are we done? Almost. If you want me to enlarge it again, I can do that. But I think it's okay. So you are creating colon districts, colon population, colon cases underscore 2023, bednet PCT, which is bednet percentage, and then IRS also PCT, which is percentage as well. IRS percentage. So once you do that, once you finish, just type districts, the name of the data that you have created, and run it. If you run it, you are going to have the answer in the console. But if you want to view it in another tab, you just put view, like I showed you the other time, view the name of it, and then it will show in another tab properly. I want to believe our online participants are also putting their hands on the work. So if somebody is working online, can I hear you say, I'm working?
Yes, I'm working.
I'm working.
Good. I'm happy to hear your
I'm
feedback.
working.
Good. Thank you.
I'm working.
Yeah, thank you. Okay, you need my attention? You need my attention? Are you done? Okay. Now raise your concern. Okay, so what's the error saying? Yes. 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 Which argument this is missing? Yes. Did you put your district? I want you to look at it. Just look at me. District, did you put it in quotation? Good. Let's go on. Letters, capital. Then you have square brackets. Is this square bracket? Are you sure? Check. A square bracket, it should be square brackets, not just curved parentheses. I mentioned the other time. This is for indexing, actually. We did indexing yesterday. So when you want to index, you index with square brackets. So have we changed it? Then 1 to end district. Have we done seen that? Then close that square bracket. Then parentheses. The parentheses is to close the first one that you open with paste, right? Then comma. So confirm that you have every other one too well written. So once you have error, don't be afraid of any error message you have from her. Error message is a way of also helping you, right? To do things rightly. So once you choose error at you, read the message, and then you can understand the message. Let me show you that one of the things you can do as a beginner is that if you get an error message and you are not able to decode it as a beginner, you can also consult AI. Just copy that error message, put it on AI to interpret for you in case you don't understand. That helps you not to get stuck. Is that okay when you are alone? But I'm not talking about this class, so I'm just talking about when you are alone and then run into something like that. So over time, you get to know how to read the error message without the help of AI again, because by that time you'll have known out what the message is saying. Yeah. Okay. No, she don't give you error again. If this is what you put. Okay, bring. Let me see. You also need to check that you have not used
your cases are not where you're supposed to use capital, you're not using small, where you're supposed to use small, you're not using capital. How is case sensitive? So all of those things can also play out. But nevertheless, you can let me see it. Okay, how many of us are succeeded in doing this? Good. Do you have your data? Oh, beautiful. What does your data look like? What do you have on your first? See, it says error in this guy, right? This, and it says this guy is missing with no defaults. So I have paste districts, letters, and districts. Have you run the end districts before? Where's your control P? Okay.
What does in this set see? What does it mean?
Is to control the randomness. Mhm. So check on the issues. It's no problem. It's no problem. That's no problem here. Mhm. That's no problem. Yes.
Any partition?
No, we don't need any package. So go on, maybe let me give them so that they can help you, so that I can concentrate on others also. Yeah, I think it's having some error message here, but I'm checking each of the entries. They are correct. I don't know where maybe there's supposed to be a comma somewhere. Oh,
District.
see what you have. See what you have. You put comma in front of this, and that's the last thing you're supposed to write. And you put comma there.
Thank you.
All right, thank you. So, one thing is that you have to be careful in typing your codes, right? What it just, you know what, the only thing that has put him in trouble since at the end of the IRS, after the last parenthesis, there is still put comma. So R is saying that I'm still expecting more. Because when you say comma, you say the discussion has not finished. You said so it's expecting another, hold on. Do you understand? You know that I've told you that what did you use to separate the columns? When you want to type another column, what do you use to separate it? Comma. And then you give another one. So once you say comma ahead, so R is saying yes. Let's keep talking. And then you stop talking. And then it tells you, no, you cannot stop talking. Because you have said you want to keep on talking. So if you want to stop talking, you should actually say, indicate truly that you have to stop, you are stopping. So that's what happens. So we have to be careful with the way we put So do you have this? Did you try view? Yeah, beautiful. So what do we see now? We see different districts with their data, right? District A with its population and cases and bed net percentage usage and RRS percentage. Is that okay? Up to district H. So meaning that it's possible that we can create a data set like this. All right, can we go on? So next thing I want to do now, because one very important thing that we do in data is data wrangling, or what we call data manipulation. Is that okay? And a very important operator is the piping operator. What do I call it? Yes, it's pipe operator. It's called pipe operator. Is that okay? That operator comes from dplyr, the package dplyr that we loaded yesterday. So if you have shut your system by yesterday, so this pipe will not work until you run library dplyr again. Is that okay? If not, I will you, because any function that is not from the base R, you know, I told you that R works by functions. These functions, some of them, these functions are in packages, right? And it's possible we have some functions that came naturally with R, for which you don't need a special package. Do you understand? So for such function, you don't need to load any package to use. You just do that. Like min, for instance, min is from base R, so I don't need to load a package to get it. But special functions that you need to load a package for, you must load those packages before they become active, before they can work. So this thing I want to do now, you know, I'm just doing a bit of data manipulation thing. I want to create another column in an existing data frame. I already have a data frame existing, but I want to add something. Maybe, for instance, you have gone to the field, you have collected your data, and then there is something by estimation that you need to get. Are we together? For instance, now what I want to add now is called incidence per 1,000 population. Is that okay? Incidence per 1,000 population. Once you have gone to the field to collect our people, it's not 1,000 incidence per 1,000 population that collect. Is that not? It's incidence that you are collecting. But it is now you who needs to now add that in order to know. But when we say incidence per 1,000, what we are saying is that of every 1,000 individual, how many people get this? So it's one of the ways of measuring body, malaria body, you know, in the epidemic space, in the public health space. So I want that metrics to be added to my data frame that's already existing. Is that okay? So how do I have an existing data frame? That's how do I put another data inside? So I can do it directly also from this R, but I'm just now making us to use the dplyr from that we added yesterday. So, and I call this pipe percentage greater than percentage. It's called pipe. And the way it sounds is like you are saying then. So it helps us carry out operations sequentially. Do you understand? Start from this, then this. So are we together? You are saying start from this, then based on where you are, then this, you are adding up, you are building up. So that pipe thing helps us to build up something. Are we together? Are we together? Then mutate can help us to either add or modify our columns without we altering the data frame shape. So look at what we have now. I have district data set already, isn't it? So let's call it again. So I want to retain the name, but I want to do something to that data set. Are we together? So I retain the name district. So call district and assign it that name again. District So I'm now saying, go pick the district that I have before, right? Pick the district that I have before. Then, is that okay? So you had also your then, percentage greater than percentage. That's then. Then mutate. Is that okay? I'm leading the ones to then mutate. So when I say mutate and I put this inside, I'm saying then add this colon, create this colon that bears. Are we together? So add another colon. But this colon that you are adding is going to be named what? Incidence per 1,000, right? What is going to fill that column? What is going to fill that is from your district data that you have. Cases over what? Population times what? 1,000. Is that okay? Are we together? And I'm saying whatever you get, they round it up to the nearest one decimal place. Is that okay? Yes. So you see now you can go to the field, collect data, and then by the time you come back, you need certain things based on the data you have collected. Like I said, what they go to collect is incidence. It's not incidence per 1,000 population. That's not what they go to collect. It's incidence. But me, I need incidence per 1,000 population. In my data frame, I need to create it. So I just, okay, what based on my data that I have, create another column, call it incidence per 1,000. Then what should be in that column? What should be there? Should be cases. That is going to be taking the column cases. Cases underscore 2023. And then going to be divided by population. And after that, multiply by 1,000. And it will round it up to the nearest one decimal place. So once you do that, close your parentheses here. And then call district again. You will now see by the time you call district again, it would have added another column that was not there before. Is that okay? You didn't have to use manual way of calculating the 1,000, the incidence by 1,000 population and not be filling it one by one. No. Since you already have incidence, you already have cases in your previous data, you also have your population. So you can just ask R to generate that other one for you and to fill it and create another column. Have you done that? Good. So when you now view your data, what do you have do you have something of this nature? Do you have incidence per 1,000 now? How many of us got this? Good. I have one person who has finished. If online people, if you are getting it also, you can tell also. So let me see. Okay, only one person has gotten it here. Yes, they will be different. Because you generated your numbers randomly, right? The numbers were generated randomly, so you are not expecting to get the same that I have. In fact, if you go to the next person behind you, it will be different too. These are randomly generated numbers, right? If I wanted it to be the same, what would I have done? I would have given you the same data. All of us will have the same data, and then we work on it. Is that okay? But we generated the data random. These are hypothetical data, so it's okay. But what is important now is that you have another column, right? Isn't it? Called incidence per 1,000, isn't it? So how many, who else has gotten it? Any challenge? Any challenge? Any challenge anywhere? Okay, your one. It didn't show. That means you didn't finish up this. You didn't do this. You didn't run this. You run. So if you run it and then you call this, it must bring it. No, you did not do what you are supposed to do. That's all. So it's to now know. It's showing error. You see now. That's giving you another level. Yes. Could not find what? Because you didn't run your deep line function that I asked you to do to run.
that percentage greater than 1 is an operator in dplyr, right? So do library dplyr, run it, and then now run that thing again. That was why when I started, I mentioned to you that now there are functions you use that are inside certain package, right? If you don't load the package, the function will not be active. So you need to make it active by loading it. So have you tried this? Do you have it now? So that means YouTube did not load before. So, but it has now come out. No, it's not network. It doesn't use network. Maybe it doesn't like the first finger you used. Check the finger you used. Maybe next time. Don't use it again. Well, anyway, that's on a lighter note, but I don't know what has happened. Okay, are we together? Have we all gotten it? Is anybody having any challenge? You're having a challenge, just put up your hand, somebody can help you. On this table, are we getting it? We get what are going to something, just that. Okay, so let's move on. If you have gotten something and somebody is having a challenge beside you, help the person. The more you help others, the better you become. Okay, so we have now created data frame. Is that okay? So we can check summary of our data set. You know, yesterday I told you that summary statistics. Can you mention to me some of the summary statistics that we have? Do you remember I mentioned something yesterday? Summary statistics. Max, which is standard deviation, and then minimum, yes. Max, then we talk about max, minimum, right? The mean, and then what again? Standard deviation, you can check variance. As there are many things that you can make. The summary study, some like, okay, now, rather than checking each of these summary statistics one by one, you can just use summary. Summary will just give you everything at once. So type summary and put the name of your data. Now, this one now, you see what I've done here? I want to look at what I've done. You will notice that my data set is district, right? Are we together? Are we together? Now, any data set, I want you to pay attention now. Any data set has row or column, isn't it? Are we together? Now, unlike vector, if you have vector, a vector, if you want to subset vector, for instance, yesterday when we created rainfall, right? If I want to get the third component of rainfall, what do? I just do rainfall, then square bracket 3, isn't it? Just to get the third component. Is that okay? But now, if I want to get a certain component of a data frame, I need to be able to specify the what, the row, and the what, and the column. Are we together? So now look at it now. Because summary, when you run summary statistics, first and foremost, I want to be able to look at those entries of this data set that are numerics. Are we together? Which of them are numerics? In the column of the data you have created, are they all numerics? Yeah? Are they all numerics? Which one are numerics? Population cases, right? Birth net percent. So now, let's say I'm interested in just checking summary of only a subset of the data set. I'm not interested in checking the entire data set. I can check summary of the entire data set. You can try that first. Summary of the entire data set. Just do summary, then district, close it, then run. Summary, district, and run. Then we want to now check summary of just a subset of that data set. So when you do summary, district, what do you add? Then you run. What do you add? Good. Good. So it tells you that for the column that is district, right? It tells you there's a character.
Is that not? Did you see that? Did you see that it tells you that we have character? What else? What did it say? So it's going to be telling you something about each of the columns, right? The columns that are the one that is character, it tells you that it's character, it tells you the number of entry. Did it not tell you that? Right? But the one that is not character, that is numerics, is going to be telling you the minimum, it's going to be telling you the first quartile, it's going to be telling you the median, it's going to be telling you the mean, the third quartile, and the max. Is that what you have? Yes, good. Are we together? So as a goal, you can see what is happening in each column. For instance, now the one that I have done here is that I have tried to subset the data set because I was not interested in seeing the summary of all the entire data set. So I said, just pick these 3 columns for me. I want to see the summary of it. The 3 columns that I want are what? Cases, bed net, and what? Incidents per thousand, right? Now, because again, I wanted all the rows of each of these columns. So I didn't specify any column. So because normally here, something should come before comma. Is that okay? So let's if I put 1, what it's going to do now is that it's just going to put pick the first row, first row. Right? Do you understand? If I put 2, it's just going to pick the first, it's just going to pick the second row. If I put 4, it's going to pick the 4th row. But let's say I want the first 4 row. So I put 1:4. So it's going to pick the first 4 row. But here I want all the rows. So I didn't specify. Is that okay? So I just leave it that row part empty and I say comma. Then I go to the column to select the columns that I want. And in selecting the columns that I want, I put all the columns that I want in what? As concatenates. No, and I now put them in quotation. So I want this column, I want this column, I want this column, right? And then I want you to help me give the summary. So I have this. I think you have the something with you. You can work with it later. At least you have done that of the entire data and you have seen it. Okay, so next thing, sometimes we have come up with data set and you want to visualize your data, right? Because the next thing, actually, when you in data analytics, the very first thing you want to do is a kind of exploratory data analysis. You want to explore your data. You want to see what is contained in the data. You want to know the way the data behaves, but there are depths about exploratory data analysis, right? But the very first thing that you want to do is a summary, right? The next thing you want to do is to visualize. Do you understand? So, which we are going to see, I want to visualize our data so that we get a kind of visual or mental picture of how our data looks, right? So, again, in R, there's a base R way of plotting. And that's what I'm introducing here. There's a base R way of plotting. But the one I'm using here is what we call grammar of graphics, GG plots, right? That one is a bit more advanced and then has a lot of other features that are very useful that you can control, much more than the one in the base R. In the base R, we just use plot, P-O, small P-L-O-T, and then you can do a lot of things with it. Since I'm not going that direction, as you read further by yourself, you can get more around that. I'm going now into GG plots, which we call of graphics. Are we together? Plots. It is called GG. Two important things you must put there. First, the data, the name of the data that you want to visualize. Is that okay? And the second thing is the aesthetics. What do I call it? Yes, the aesthetics are the X and the Y axis. Are we together? Is that okay? Are we together? So you must specify these two things first. You cannot plot anything if you don't first specify them. So you must be able to tell us what the data, the name of the data you want to visualize is, and you want to tell us the aesthetics, the X and Y axis. Do you understand? Then next, we now begin to bring in the geometric objects. That is it a line that you want to plot? Are we together? If it's line that you want it to come out with, you call it, we have geometric objects. So that star that you see there means that you have to fill it with whatever type of plot that you want. It can be geom line, it can be geom points. Do you understand? So if you put geom line, that means you want line plots. If you put geom points, that means you want points. Do you understand? All right. And many other things that are there, you can control your color, right? You can control color using scales. Specify the kind of colors that you want. The coordinate system, you can control it. The thing that is your font, the background of the picture, the grid lines, you can control them. A lot of things you can control using ggplots, right? So these are layers telling R of how you want to control your outputs, your plot outputs, and that's where the beauty comes. And in fact, I must tell you that there is no up-to-date, no known programming language or software that produce quality graphics as R does. No, I'm not trying to say R. It's the truth. It's the truth. No, I'm just telling you the truth. You can search. Yes, no, not for now. Maybe tomorrow somebody else might wake up and do something else. Not even Python. Yes. No, not smart. Which MATLAB are you talking about? You can control a lot of things in this place. How is strong? Tell you that one. Very strong. Which maple are you talking about? It's not, maple does not even come close. So you can search actually if you need anything called vision. I mean, you just need to work with R. You can control a lot of things. It's just that's the strength. It's one of its strength anyway. But you can also come up with something that is very strong. Okay, so let's go on. I've told you that the very first thing that must be created is what? This ggplot, the first line, right? And each of the layers that you add, you only put plus, you only use addition sign plus to add any other layer. Meaning that, okay, for instance, I want my plot to look like this. Everything you consider in your mind, you have your plot to look like this. Have half a of everything. So just like plus, up to whatever you want. Is that okay? But the very basic ones you must have is, for instance, I've said geo. This is ggplot, the name of your data. So let's create it now. Let's create a ggplot of the data set that we have created. That df_monthly that we created that time. You remember? That has what months, cases, and what? And rainfall. We want to visualize that one first. So I know it has three things. Is that okay? Now, you see one big thing about this that we're about to see now. So you put the name of your data, df underscore monthly. And then the next, the aesthetics. Your aesthetics, three main things that you can have, two first primary, but you can have it up to three. Two primary thing you must have are the axis, x and y axis. Right? The third one you can have is the fill. Fill there is to indicate how you want the color to be regulated. Is that okay? Now, you see that I put fill equals to rainfall. That means I'm saying that based on the intensity of the rainfall, right? Let the color vary. The color now I'm plotting on x-axis month, right? All these that I'm putting here must align with the name that's inside the data frame. The data you are putting, you know, it's data df underscore monthly. The columns, the name of the columns must align. So I'm saying x-axis. You remember that we created the column column, right? You remember, right? The next one is cases. You also remember we created cases. So I want my cases on the y-axis, and I want my month to be on the x-axis. When it is plotted, I just want to see how cases vary over time. Is that okay? Are we together? And I want the color of each of the cases that we see over time to vary according to intensity rainfall. Is that okay? That's why I said fill. So you can see bar fill color. So write that. So I've told us that the geom is another thing which to specify the kind of shape you want. Is it line? Is it point? So you can see now there are different geometric objects in R. Is that okay? So you have geom line charts. You can use geom line for line charts. You can use geom points for scatter plots. Is that okay? You can use geom smooth for this trend slash regression line with confidence band. So this one just it's smooth line on top of your plot if you are using geom smooth. Then geom histogram is to, if you want your plot to be histogram, geom box plot if you want it to be box and whisker plots, and then geom ribbon in case you want shaded area between two values. So you specify all these things as you want it to be. So these are different geoms that we have. And then we can have many of those geoms. You can stack them at the same time. For instance, you want to have a point. You want to have a line of different data from the same and from different data. For instance, I want to view rainfall and cases at the same time. But I want my cases to come as points, and I want my rainfall to come as line. I can stack them and use different and then the other one which has to do with scale is for controlling axis and colors. So we'll see how we go about that, the way colors are controlled. Yes, and then okay, so let's quickly draw that. So we are going to just draw this, and this is going to be the last point where we stop for today. So let's quickly plot that. So so we plot this and then we just end the class. Okay, okay. I think I should stop here because you also have the codes you can run them. I think I've sent them to you to be able to practice with. So we'll stop at this point. So by the time you plot it, you are going to see something of this nature, right? So you are going to see something of this nature. So by the time you do that, and in case I have any other time to come up again, if it's possible, then maybe I will just touch on modeling parts. So, but I don't know if that will be possible. All right, thank you so much, and let's enjoy the rest of the day. Okay. Okay. Yeah. Okay, so it's the last thing. If you want to eat now, let's go and eat. Then we come back and then we finalize.
For example,